Hey, my science lovers! Today we're going to look at how to do the electron configuration, making an Aufbau diagram, and only looking at the periodic table to do that. Our periodic table, we got this from ptable.com, which is an absolutely sweet site that I love. So first little bit of terminology. When we go left to right across the periodic table, that's called the period. I'll put a period there to help us. And when we go down the periodic table, that's called the group. So left to right, that row is the period, down is the group. As we're going left to right across a period here, we see it's arranged by the atomic number. That's the number of protons. So very important we know that the periodic table is arranged by number of protons. So we see the number of protons increases by 1 for each one of these elements as we're moving left to right across the period. And when we get down to 6 there, we see that it jumps down to that little box at the bottom, then it jumps back up, and then it goes back up. And then 7 goes down to that little box and then goes back up. And we'll see when we expand the periodic table how that fits in a little bit better. But if you follow the number of protons, looking at your periodic table, you'll see that they follow along. So the neutral atom, whenever we have a neutral atom, the number of protons will equal the number of electrons. And that will be important for us today. Let's do just a little conceptual flow diagram of what we are doing today. So first thing we want to look at is the principal energy level. That is abbreviated N, and on the periodic table we have energy levels 1 through 7. And those we'll see are going to be on the left side of the periodic table. And then we're going to have these 4 sublevels. I'll color code them for us today. We have the S sublevel, the P sublevel, the D sublevel, and then the F sublevel. And in other videos, we've talked just a little bit more about their shapes. And those are the orbital shapes of each of those sublevels. So the S sublevel, it has 1 orbital, and that's going to be a spherical one. The P sublevel, it has 3 orbitals, and those will be like dumbbells. And then the D sublevel, it has 5 orbitals, and those are kind of like clover leaves. And then the F has 7 different shapes that it makes. So 7 orbitals in the F. And now in each orbital, the rule that we want to know is even though they're making different shapes, an orbital is only going to have 2 electrons. So even though these orbitals have different shapes, each is going to hold 2 electrons. And we abbreviate those electrons with an up or a down arrow. Up arrow being clockwise, down arrow being counterclockwise. So each orbital is holding 2 electrons. So that means the S has 2, P 6, D 10, and F had 14 electrons when we count those up. If you're enjoying this experiment, could you honk that like button? I appreciate it. That helps it spread to more people. Now let's look at how this knowledge, our principal energy level, connects to the periodic table. So as we go down there, we saw 1 through 7, those energy levels, and we'll just keep doing that. Energy levels 1 through 7. So as you go down in your groups, that's kind of like moving when you see these pictures of the nucleus. So it's kind of like the nucleus is at the top of the periodic table and those lower energy levels are at the bottom. Kind of, okay? It's not exact because we're going to see that there's a lot of weird little overlaps. So again, energy levels 1 through 7 moving down the groups. Energy level 1, 2, 3 moving across. But then we have this jump when we get to 4. We skip that middle section. And we'll see that middle section actually bumps up in energy level. And same thing happens on 5, 6, and 7 right there. It'll look like they're on a certain energy level, but then they're not actually. And then F actually bumps up 2 energy levels. So once we get back to the P though, or that far right section, we'll see that it goes back to the normal energy level. So 7, then it goes to 6, back to 7. And what we're going to do right now is we'll see 6 and 7, they're pretty wild. And when we expand the periodic table here, we'll get some clarification. So we have energy levels 1 through 7, and we can see that these, the LA and AC, they are these circled and squared elements up on our wide periodic table. So 4 goes across, and now we get to this middle section. It goes to 3, and then it goes back to 4, 5 jumps to 4, and then back to 5. When we get to the far right, 6, and then we go to 4, then we go to 5, and then it goes back up to 6, And then 7 jumps to 5, jumps to 6, and then goes back to 7. So one thing that'll help us is once we have named these and look at what they are called with their sublevels. So the energy levels on the far left, now these sublevels, those first two groups, they're called the sublevel S, sublevel S right there. And they only are going to have one orbital, which means they'll hold 2 electrons max. We see those electrons are spinning opposite ways. Then on the far right, in purple, that's going to be the p sublevel section, the p sublevels. Those have 3 orbitals, each holding 2 electrons. And so that's 6 electrons max in the p sublevel. And then the D, don't forget those 2 that are down at the bottom of your periodic table. Those are going to have 5 orbitals, each holding 2 electrons. And we'll practice this, but we'll see that we go all up first and then down, and that's 10 electrons. And then we have the very bottom section of that periodic table, the Fs, and there are 7 orbitals, each holding 2 electrons. So that's going to be 14 electrons max when we get down into the Fs there. So S, P, D, and F sublevels connected to our periodic table now. And one thing that will help us also is if we look at what that looks like in terms of the wide periodic table. So there's the S, the P is over on the far right, the D right next to the P there, and then we have the F sublevel that is right next to the S. So that's how they shift over. And S has 1 orbital, P has 3, D has 5, and F has 7 orbitals. So I'll use this wide one as a little bit of a reference. And these orbitals have different shapes, but each is holding 2 electrons that are clockwise and counterclockwise. Now, when we draw an Aufbau diagram using our periodic table, we're simply moving left to right across the periodic table. So when we say the energy and sublevel, the sublevels S, P, D, and F, we're going to be moving left to right. So we'll start at energy level 1 going left to right, then we'll go energy level 2 left to right, energy level 3 left to right, so on and so forth, and just write down the orbitals and sublevels and energy levels that we happen to come across. So let me jot down the energy levels here so we can see them. And what is the first thing we come across? The first energy level has the S sublevel and it has 1 orbital. Then we go across, and it's still part of that first. Then we get to the second energy level, S sublevel has 1 orbital. Then we jump over, we're at the second energy level, P sublevel, and we know it has 3 orbitals. Then we go back up to the third energy level, the S sublevel, and it has 1 orbital. Then we go across the third energy level, P sublevel, and we know it has 3 orbitals. So 3 orbitals in that 3p. Then we're at the fourth energy level, S sublevel, with 1 orbital. Now we have to keep in mind that the D sublevel moves up 1 energy level. So instead of being 4D, we're actually going to be at 3D here. So 4S does not go to 4D, it goes to 3D. So we go up just a little, and we have 5 orbitals in the 3D, and then we keep moving across, and now we're going to get back to the fourth energy level, P, so 4P, and sublevel P. Then we go down to the next one, and we're at 5, energy level 5, sublevel S, 1 orbital. And what do we run into next? It looks like we're at 5D, but we go up 1, so it's actually going to be 4D. So we put down our 5 orbitals, and it is 4D there. Then we keep going across. We're back to the 5th energy level, and we're at 4P here. So Oh, sorry, I said 4p, 5p. We're back to 5p. And then we jump up to 6s on the next one. Now, what's the next thing we run into? The F. In the F, it looks like it's on the 6th, but it actually goes up 2 energy levels. So we're going to be at 4f because it moved up 2 energy levels, 4f. And it has those 7 orbitals. Then it looks like we're on 6, but we're actually on 5 because the D level moved up 1. And then we're back to 6p. We're back to 6p there, and 6p has 3 orbitals. And now we're down to the 7s, and I'm about out of room, so I'll just do the 7s, and then the next thing we run into is it looks like you're on 7, but we're actually on 5, so the 5f. So if we're looking at these, just drawing arrows going across, it goes 1s, 2s, and then across to 2p, and then we have the 3s, and then across to 3p, and 4s, and then across. Now we don't go to 4d, we go to 3d here, and then it goes back to 4p, and then we're at 5s, and then it looks like we're at 5d, but we're actually at 4d, and then back up to 5p, and then we go to 6s. Now here's where it gets a little tricky. Then it goes up 2 levels, so we're at 4f, and then it goes up 1 level, we're at 5d, not 6, and then we're back to 6p, and then we're at 7s, and then it looks like we're at 7, but it goes up 2, so we're actually at 5f. And that is how we fill those. That's how we write that Aufbau diagram. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. 4d, 5p, 6s. 4f, right there. 5d, 6p, 7s, and 5f. 5f. So that's how you make the Aufbau diagram. And those are super helpful, folks, like so helpful. When you're doing electron configuration that we're going to look at right now, you can get tricked if you don't do the Aufbau diagram because your teacher oftentimes will not tell you which ones are the exceptions, and that will save you. So step 1 when you're doing electron configuration, if you really want to make sure you get it right, is draw the Aufbau diagram, then do the electron configuration. Let's do hydrogen first. So hydrogen first. We got our energy sublevel, SPDF. Hydrogen, easy one. We're in the 1s, and it has 1 orbital. So here's our rules when we're doing Aufbau diagram. Each atom on the periodic table represents 1 electron. So when I think of electron configuration, it's telling me where are the electrons that are in hydrogen. So in hydrogen, there's only 1 spot there, that first atom, and the first atom, the first electron is always up. So to answer this, in hydrogen, in the first energy level, in the S sublevel, there is 1 electron, and it's spinning clockwise, if we wanted to be a little more specific. And the way we write that electron configuration is 1s1. So energy level stuff for us, we'll do orange here, and then it's in the S sublevel, and there's only 1 electron that's there. So again, first electron is always spinning upwards. That's clockwise. And it's important to be able to interpret what your electron configuration actually says. A lot of times people can write it, but they have no idea what it means. So beryllium here, that's our next one. We'll write our sublevels and energy level here. We have to fill all the lower energy levels before we fill those higher energy levels. That's another rule of filling these. And there's another video on that you can check out if you'd like to see where some of these rules are coming from. There's some famous guys who came up with them. So with beryllium here, we have to fill the lower energy level first. That's the 1s. So the first electron went up, and then that next spot, what would be like helium, got the down arrow. So we had 2 spots. And then we had 2 spots that were going over to beryllium. So hydrogen, helium, we're in the 1s. Lithium, beryllium, were those second 2 electrons right there. So the first electron always goes up. The second electron always goes down. And that's our counterclockwise one. So where are the electrons? There's the 1s and the first energy level in the s sublevel are 2 electrons, and the second energy level in the s sublevel are 2 electrons. And that's where they are in beryllium right there. So again, in the first energy level, that's n equals 1. In the s sublevel are 2 electrons, and in the second energy level, in the s sublevel, are 2 electrons. And each spot on the periodic table represents an electron that you're putting down in your electron configuration and in your Aufbau diagram. So let's do 2 more examples, and then maybe later, another day, we'll just do a video of a whole bunch of examples. Let's do iron here. So iron, we go a little further down. We got S, P, D, and F. We have to fill up the S first, those lower energy levels, and it had 2 spots. Then we had 2S, and it had 2 spots. Then we had 2P. We go all the way across to neon, and it had 6 spots. And remember, the first electron, we always do 1 electron in each first, and those first ones always go up. And then it goes down, down, down. And then we have 3S, and there were 2 spots. And then we had 3P, up, 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 down, down, down. And then we go to 4S. We had 2 spots, up, down. And now we get to the D sublevel. And it looks like 4, but it's actually energy level 3. So we draw our 5D orbitals, and it's 3D, and there are 6 of them. So we got 6 little electrons. The first 5 go up, the last one goes down. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And each of those little exponents are telling us how many electrons are in a given sublevel and energy level. So bromine, last one here, bromine. We got to go a long ways. So 1s2, 2s has 2. 2p has 6 spots, so we put all 6 of those electrons in. 3s has 2 spots. 3p has 6 spots. We put those in. 4s had 2. 3d had 10, so up, 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 down, down, down. And then we go back to 4. 4p, we go up, up, up. And then bromine is 2 more over, so down, down. So that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5, and that is bromine. I hope that was helpful. If it was, come back next time and we'll do some more, and I'll talk to you soon.